So, hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, it's always great to be here on these AskTOM Office Hours sessions to answer your questions about Oracle database and SQL. As always, we generally have a topic that we're going to cover this time with the 20C docs being released a couple of weeks ago and the preview version being available. Thought it'd be a good time to cover some more of the odds and ends that have arrived in SQL in this release. So we'll cover some of those in this session. Talking about 20C stuff, this is in preview mode, so hopefully everything should be working as I say, but obviously things may change. So disclaimer, things might change between now and future releases. Bear that in mind. So there's some various odds and ends that I wanted to cover in this session. So a few months ago, I talked about some key cool things that are coming in SQL, the new windowing clause, SQL macros, were the main things. This time, there's a whole bunch of kind of more niche SQL functions that have arrived. Just to talk about some of those kind of quickly. Another feature that we've added, which does seem quite popular, is blockchain tables. So we'll talk about how they work. And based on a poll I did on Twitter last week, JSON data type, so a new native way of storing JSON in the database. So that's new in 20C as well. So I'll have some slides, kind of walk through those briefly, and do some demos showing you how those work. All right then, but before we get into that, let's divert completely and talk a little bit about the art and science of love. Or more precisely, let's imagine we're building a dating application. And what we're trying to do is figure out ways of matching people, matching partners together. So there's loads of these dating applications, and what the goal is to try and get people together who are compatible. And there's various ways you can do this, but you can look at things like what their hobbies and interests are, their likes and dislikes, and so on. So these people might have various likes and dislikes, and what we want to do is find the people who have the most in common. So, and the theory being that if you've got lots of stuff in common, you're more likely to get along, and therefore you're more likely to have a successful relationship. So that's what we're trying to do here. We want to find out how much these two people have in common. So what we can do is, for all these various characteristics, have a table of kind of ones and zeros. So something a bit like this. Say for each person, whether or not they like that particular thing. So we can see both people here like SQL. They've got great taste, so that's perfect. One of them likes travel, one of them likes pets, but not vice versa, and neither of them are particularly fussed on films. So because we've got this data stored as kind of ones and zeros here, we can do a comparison, see how similar they are just by doing bit truth tables on them. So for example, ANDing the two things together. So if we AND the values in the columns together, we'll see that we've only got a 1 for both of them in the SQL column. So that is the only one that hasn't 1 when we AND them. The rest of them are all zeros. So maybe they're not compatible, maybe they're slightly compatible. But the thing is, maybe they're not too fussed about travel and pets. You know, one of them really likes it, the other's not too bothered, but maybe they're still compatible. So we could do an OR instead and say either of them have a particular value. And we say we're getting a lot more ones in here. So looking like they are possibly more compatible. Or it might be that there's some things that you'd like and have disliked. So we can see here, person A really likes having pets, but maybe person B just hates animals and really doesn't want pets at all. Not a good start for a relationship, right? They're probably not going to make good long-term partners there. So rather than finding things that are the same, we could do an exclusive OR and just find where those are different. So we can see, do an exclusive OR, and we can see there's difference on travel and pets. And if some of these are like strong dislikes, then a high value for exclusive ORs, or lots of ones here, will tell us that probably they're not that compatible. And then we can plug these values into some algorithms or do some computation on there and kind of produce a matching score based on how likely we think these people are to get on, and then suggest them as potential future matches. So that's what we want to do. And in 20C, we've added some bit aggregation functions to help you do this. So we've got these new bit and or and XOR aggregates. And they do kind of what they say on the tin, really. You pass them in a numeric or a set of numeric values, and it converts them into their bit representations, the ones and zeros, as they would be stored machine-wise, and then crunches them to figure out the final bitmap to produce a value, so we can see whether they are whether or not they're compatible. So if we go back to our table here, we can see person A and person B. So working left to right, so if this is a binary representation of the number, then we've got our 8s, our 4s, our 2s, and our 1s. So this first person, the decimal value of this binary is 10, and the decimal value of this binary value for person B is 12. So if we're putting 10 and 12 into these aggregation functions, we'll get those binary values, which are these decimal values. And we can use that to kind of, like I say, then figure out, have some matching algorithm. Obviously, if our ands have lots of 1s in here, it's a good sign that's probably a good match. If our exclusive ors have lots of 1s, maybe they're not a good match, depending on if somebody's tag these as strong dislikes and so on. So we can use that to feed into our algorithm of whether or not people like this get on. And this is a good way to rate compatibility of people. And apparently this is something that dating applications do quite a bit. If anyone here has either worked on a dating application or is currently working on one, I'd be interested to see whether this at all represents what you do, but let us know. Any questions or comments on that at the moment? Okay, no, I'm not seeing anything come in yet, although a comment from Judith. There was once a nice feature called expression filtering that could do such things that Oracle obsoleted in 11G. I'm not familiar with that one, Judith, but well, if it's obsolete, then it's probably not coming back. Anyway, so we can do this to kind of compare people and do some matching, but if this is quite a niche thing, right, doing that kind of matching. Or is it? Well, there might be some more general uses for this kind of approach. So let's say you've got your sales and marketing team, and they want to do some analysis of what people are actually buying. And they want to look for people who are repeatedly buying the same set of products. So we've got products A, B, and C, and they want to know who keeps buying those same products over and over and over and over. Maybe they're going to target them with promotion, see if they can upsell them some other products, who knows, whatever. They want to know who's buying this basket of products regularly, or maybe who buys this basket of products at ever. So we can then have some promotion or something based on that. So we can use these bit aggregations to do that kind of analysis. So we've got our kind of standard order items table, which you're all probably relatively familiar with, where you've got your order and you've got your products within it, quantities, and so on. And what we want to do is find out who's got orders where that product appears many times. Well, what we can do, we've got our products in as rows in the table. First, we could convert those into columns. So we could pivot the data. So we've got product A is a column, product B is a column, product C is a column, and so on, as a series of ones or zeros to show whether or not they've actually purchased it. We can then convert those ones and zero columns to a decimal value with this bin to num function. This is one that's been around a long time. Not quite sure how long. I haven't checked thoroughly, but it's been here for quite a while. So we can just pass in a series, keep a large series of ones and zeros and get the decimal value of those, and then aggregate them together. Again, that gives us a final decimal to show how often this happens. And we could filter that, if we want to find everyone who's purchased all of these multiple times or every single time in a data set, we can say when whatever the maximum value of that binary number would be. So we can use this to kind of do analysis to see repeated or who's buying what or who's buying the same thing repeatedly. So potentially particularly kind of useful there. But maybe the sales marketing team want to do a bit further analysis. You know, it's always typical, this kind of thing. If you've ever done it, they'll give you a request, you'll produce some data for them, send it to them, and they'll immediately come back with some other requirement or question that they want answered. So they're going, oh, okay, we see that. Well, actually, maybe what we were really looking for was who has bought exactly the same thing, or how many times have we got identical product baskets? So not just the same products, but exactly the same quantities of those products, exactly the same purchase price for those products, and so on and so forth. So we want sets of baskets which are completely identical. They have same products, same quantities, yada, yada, yada. And this is actually can be quite tricky to solve with standard SQL, because essentially you've got sets of rows you need to compare against other sets of rows in the data, and there could be a large number of these. You know, there could be, you're comparing everything against everything else potentially, which can give, you know, a factorial explosion in the amount of comparisons you need to do. Now, you might get some of the way there with sets operators, things like union, minus, intersect, and so on, to do differences in comparison, but it's still a little bit fiddly. So it would be better if we could just take a set of data, some rows and columns, and say, produce a checksum or a hash of that, and then use that to compare values. And so that's something we've added. Another thing we've added in 20C is the checksum function. What you do is you pass it an expression, aggregates that across rows, and it returns a checksum, a numeric value for that. So how do we use it? That's pretty straightforward. It's just checksum and the expression you want to use. As I said, this is an aggregation function. So you pass that column from a table, it will compute the checksum across all the rows in the table. So what we can do is we can get a checksum for each individual order. So we can do something like this, group by order, and then pass in all the columns that we say have to be the same: the product, the quantity, the price, discount, anything else that might be relevant for us to consider baskets the same. So we can do that, and we get a checksum value, and then we can find if there's any duplicate baskets by then grouping the result of that checksum, checking those where there's at least 2 orders, returning that information. And, you know, depending on what exactly we're trying to find in here, we might need to join that to some other data or include some extra information in our columns. But we can now fairly easily see if 2 sets of data are in fact the same. And this is kind of a general problem in SQL. You know, if you've got 2 tables which are supposed to be the same, maybe it's part of some loading process. You've got your staging table and your main, you know, real target table. You want to be sure the contents of them are the same after you do the load. You can use set difference operators, union, intersect, minus, in various combinations to do that comparison. But that kind of only really works if you want to compare the entire data set. You know, what if you want to check that for each individual customer, they have got exactly the same information within that table? Much trickier. You have to kind of carve the data set up before you do your set differences on them. With a checksum, you can do group by customer, checksum everything of relevance, and then compare the checksums between the 2 tables, however you wish to do that. So it's potentially a neat little way to compare sets of data to see whether or not they are in fact the same. So I see a question from Manujas. Oracle has our hash function already for that? No, this is slightly different to the Aura hash function. I forget the details. I know of it exactly, but actually I have to check. I'll come back to the Aura hash function because I think that's single row rather than multiple row, but I could be wrong there. I'll have a demo of this and show you exactly how this works. Any other questions or comments on that before we move on? For checksumming product list, it should be exactly the same order from David. So you mean the order that they passed, that the rows are passed into the checksum? And don't believe so, but again, we can test that out in a little demo, see what exactly happens. The key thing is we just pass in one column and it computes across the entire data set. Like I say, I'll do a little test of that when we run the demo, see if adding an order by makes any difference there. Okay, any other questions or comments? Does this not have possible collisions? I mean, you know, checksumming, hashing, and so on, it's always possible for collisions. I don't know the full details of how likely and possible that is, but yes, you could. It is something you need to be aware of. So, yeah, I'd have to go into check a bit more to see exactly how likely collisions are. Okay. Any other questions, comments before we move on? No. Okay, cool. All right then, so you've done some more analysis. You've gone back to sales and marketing and find them the duplicate baskets, and then they come back with yet another requirement, and this time something a bit different. They want to see basket values. They want a graph of how much people are spending. So they want to see across the bottom value of the basket and up the side how many orders there are. Slightly different to previous requirements. This thing, you give them a whole bunch of stuff and then they change their minds completely and ask for something completely different. Anyway, so let's do that. Let's graph an example data set, and quite often you get data sets that look something a little bit like this. So most people spend a little bit, and you'll have a little peak of the mode the most people are spending, and then potentially quite a long tail of how much people spend. You'll have the average amount people buy in each basket, but the tail for this could get really large because technically there is no upper limit for how many people could purchase in one particular order. Obviously, if you're selling Ferraris, that upper limit's going to be a lot higher than if you're selling, reams of paper or something like that, or pens. So exactly how high that upper limit is likely to be depends on your business. But in theory, it could be arbitrary. It could be infinitely high. Well, maybe not infinite, but a lot higher. So you want to do some analysis on this kind of data, and basic statistical analysis. A lot of people will start off and they'll say, what are the various averages? What's the mode? What do most people spend? What is the typical largest, which basket value has the most people spending on it? The mode. The median, which is the middle value, and the mean, the arithmetic average. So on average, how much do people spend? And quite often people do this kind of analysis to kind of go, well, on average, customers spend £10 per basket, therefore we can do some predictions about how much our future income is, and so on and so forth. Thing is, a lot of people stop their statistical analysis after looking at just these kind of three figures. And really, quite often you need to bring in other things like the standard deviation, the minimum, the maximum, and so on. Or you might also be interested in how big this tail is, or how long it is. As I said, in theory, the upper value for an order is very, very high for a particular customer. And the higher that value is, the more it drags that mean over to the right. So if we've got a small number of customers who make, really, really large purchases, this mean is going to start moving over to the right. Mode's going to be unaffected. The median will have little or no impact on that, but the mean can start moving. So it can be really useful to know how long this tail is and how far it extends. So to help with this kind of analysis, we've got a couple of new statistical functions in the database. Not new in the general statistical analysis, they've been around for a while, but new to Oracle database. And they are we've got these skewness and kurtosis functions. Skewness is the third moment of the data, excess kurtosis, or kurtosis is the fourth moment of the data. which have these lovely looking formulas, which I'm sure make a lot of sense to all of you. Probably not. You're probably all looking at that and going, what the heck on earth does that mean? So the kind of general or loose interpretation of these is that the skewness is to do with which side has the longest tail. So positive values for this mean that we've got a long tail out to the right of the mean. If it's negative, then it will be out to the left of the mean. So is this tail stretching out to the right or stretching out to the left? And bigger values means it's more stretched. The kurtosis is to do with any outliers. We've got customers, small numbers of customers making really large purchases. They're outliers, and they will drag up that mean, giving a larger kurtosis. So in the normal distribution, the skewness and kurtosis values are both 0. So if we look at this, it's not quite a normal distribution. It's not symmetric, but it's reasonably close. We can see the tail out to the right here. It is extending further to the right than it is out to the left. So the data is slightly skewed to the right. So we'll have a positive skew there. And again, there are some values outliers. I wouldn't really call these outliers here because, our mean is just under £10 and our maximum value here is around £30. So about 3 times the mean, not necessarily really an outlier. So we'll have a positive kurtosis, but not particularly high. So these values both be fairly small. But as I said, you might have some customers who spend a lot on each order. So we could have a few higher values and some £80 orders, for example. And we've got a few of those. They drag that mean further to the right. So the data is now further skewed to the right. And the kurtosis will also be higher because we've got more of these outliers, which are going to bring that mean up. So we've got a positive, probably largish positive skew, and a fairly large kurtosis. I'll go through some more demos later if you're kind of struggling with this. It is kind of a niche feature, so don't worry about it. Probably doesn't apply to most of us. So we can see that we've got this value like this, or we could let's take the mirror image of this data. So instead of the peak being off to the left here, I'll put it over to the right and kind of just flip the data around its midpoint. So it's the same distribution, just the other way around, so to speak. So in this case, we've now made a negative skew. So the data, the tail is off to the left. And because it's basically the same shape graph, the absolute value of the skew should be the same, or basically the same. It's just in this second graph, it's on the left, and on the first one, it's on the right. And in both cases, we've got a handful of these outlying values, which are going to drag the mean up or down. So we'll have a large kurtosis for both of them, which should be about the same. So, don't worry if you don't understand this too much, because it's very useful if you do a lot of statistical analysis, but not huge use for most of us. So questions or comments on those before I jump into some demos, which hopefully illustrate them a bit more. All right then, so let's start off with these, the bit expressions, the bitmaps that we were discussing before. So we can see we can use bin to num to convert these binaries into decimal values. So we'll get 10 and 12, the values we had before, and we can then aggregate them all up together, and we'll see we got the values that I had in the slides before. So 8 for the AND, 14 for OR, 6 for exclusive OR. And it's pretty straightforward, really. If we take all the values from 1 to 10, again, I've done this time I've converted the values to ones and zeros, so taking the decimals to ones and zeros, so it's a bit easier to see what's actually going on here, and split them by the mod. So we can see there, these have nothing in common across all the values. So the ANDs are all going to be the 0, but all the even values will have the 0 for the value 1, bit position 1, and there'll be 1s in all the others. So they're 14 and 15, and so on. So pretty straightforward. They say potentially very useful if you've got lots of attributes, lots of characteristics, and you want to find customers, products, whatever that have common characteristics between them, or exclusive or differences between them. So potentially useful there. Side little thing there, another 20C thing we discussed, mentioned in the previous session, the windowing function. You see they've all got this partition by modulus of the value. We can just do over the window. Nice way to make a reusable windowing clause. Very handy if we've got multiple analytic functions and we want to have the same partition by or the same order by, and so on and so forth. Okay, so let's talk a little bit about those kurtosis and skew functions. So I'm going to generate some normal data. So as I said, the normal function will have 0 kurtosis and skew. We're not going to quite get zeros for either of them because it's random data. So it's not going to be a perfectly normal distribution, but we'll see that these values are fairly close. So these are both pretty close to 0 for our normal distribution for the kurtosis and skew. So now what I want to do is create an outlier way out to the right. So you can see the maximum value here for this one is 4. We've got a maximum of 4 for the normal distribution. So I'm going to stick a value of just under 1 million, 1 less than 1 million, 99999. So we're going to have a really long tail out to the right. And if we run this, we'll see that this will give us a big positive skew. So the skew jumps up to 2.6. And again, this kurtosis is now a larger positive value because we've got that one outlying value that pulls the average up. So I'll just pin that for a second. If we change that to a negative value, so minus 1 million, basically, this will do the opposite of what we discussed. We'll now have a negative skew, but similar kurtosis. So we run this, and we will see not exactly the same values, but similar values. So skew 2.8 versus 2.6, it's pretty close, and kurtosis of 6 versus 5. So again, fairly close. They're not going to be exact. I'm using exactly the same because we're using randomized values here. Hopefully, gives you a bit more insight to what these do. If we look at a uniform distribution, so just generate the numbers 1 to 100, so each value appears exactly once, and run that, we'll see 0 skew because it's just a line. If we graph that, it's just a nice horizontal line, and the kurtosis for that is minus 1.2. And if we've got 2 points, just the values 1 and 2, we end up the smallest kurtosis value you can get, which is minus 2, and a skew of 0. Okay, questions, comments on, questions or comments on those. So actually, let me do the, let me do the checksumming as well. So as I said, we've got a table here, and I'm going to stick some values in there. So we've got dates, numbers, varchars, clobs, and so on. We can pass all those together to get a checksum for this. Let's just close some of these other ones down. Helps if I actually create the table first, doesn't it? Okay, so let's create the table and insert the data. So there we go. We got a checksum value, 5, whatever it is. And now if we insert some more data and pass those in, we can run the checksum again. So it runs this checksum across the whole data set, and we get a completely different value. So we've changed the checksum there. So the question, David, about sorting, does it make a difference? I believe not, but let's just check. If we order by C1, well, maybe it does make a difference then. Let's see. Let's see, C2. Let's say we order by C2. Maybe let's run that again. Let's just run this again. Make sure I didn't do something a bit silly there. Okay, so we'll create the table again, checksum those. Yeah, so we've sorted them and the value is the same. So it's just computing across the data set. Order doesn't really matter here. And we'll sort by that descending, again, get the same value back out. So sorting doesn't matter. Question about or a hash. Let's see, or a hash. if we try and or hash this, let's see what happens. Should we have a guess about? You mean inside the checksum function? Oh, you mean which order you do these? So there's the order of the columns within checksum, in which case it, if we flip these around like this, so you mean like that, David? So we run that, so that will matter because they are now completely different values. So this expression is just one value per row. So it's not the separate columns. We're not passing individual columns into this function. We need to concatenate them together to make the value we are checksumming, in which case the order absolutely does matter because, they were comparing different things. It's like if we do first name, last name is different to last name, first name. Okay, they contain the same things, but if we were to do a text comparison of them, they are different. So if you're talking about inside the checksum function, the value does matter. If we're talking about the product list, we've just got a table which has row, product ID 1, product ID 2. We're talking about rows for those products, not columns there. So hopefully that helps answer the question, David. Sure, but why? I hardly understand. We can find who bought the same basket. Okay, so we've got our table like create table, order items, and we've got order ID, product ID, quantity, like that. We can pass in quantity. We can do checksum product ID quantity group by order. So that produces you a checksum for the order. So all the rows within that order, we said product ID, you probably want to do something to separate these values like this so you don't get accidental collisions on products and quantities that are the same. So for each row in the order, we're saying order ID combined with quantity, compare all those, produce a checksum for that, grouped by the order. We can then see any other order which has exactly the same orders and products and quantities will have exactly the same checksum. Does that help explain what's happening? Okay, any other questions or comments on that? Well, you let me know if that helped you understand, David. Okay. While we wait for David to get back to us, let's look at the ORA hash. So if we do ORA hash, not a single group function. ORA hash is a single row function, so it only applies one row at a time, which is kind of what I expected. So it's not like checksum because we just get it for each individual row. I mean, you can hash row by row and say, are these two rows the same and group by that, for example, but we're not saying is the set of rows the same. So I'm still not sure what you're saying, David, when you say, okay, so okay, for one by one product, but for checksumming a basket. So if we've got our order items, group by product ID, or order ID, I should say, all the rows which have the same order ID then get put into that checksum. Maybe if we stick some data in here, it will help. Yep. Well, that was an interesting thing we got there. We go order items. We go 1, 1, 1, and so we've got order 1, order 2. So order 1 and 2 are the same. They've got exactly the same products and quantities, but order 3 is different. So we will create this table, run this. There we go. Got some data in there. So we group by order ID, get the checksum, and the checksum for orders 1 and 2 are identical because they've got exactly the same. The row values for product ID and quantity are the same. So checksum is an aggregate function. So it takes multiple rows. So you can see we've got 2 rows we're producing we've aggregated those together. It's taken, however it does, it's taken one, it's basically said this, if I mess around with those, taken these two values as an input to produce checksum across those for that order 1 and order 2. They're the same, so they get the same checksum value. And order 3 has a different product in it, so we get a different checksum value. So previously used an order by to the overall query, so should have got an error. It's a good point, Judith. I hadn't, that's a good thing. Maybe I'll have to look into that in a bit more detail. Okay, so that helped answer, David. So you've got it now, you see what's happening? Okay, any other questions or comments on these? Yeah, I see what you mean, Judith. I'm not sure what's going on there. I'll have to look into that. Okay, thanks, David. All right, thanks for clarifying. So let's just, okay. You can do things, I think I've probably covered everything we need to say on this now. When we change values, if we look at our checksum from our T, we get our value, we update all the rows to sysdate, and we've now got different checksum because we changed those values. One thing to note about checksum, it does, we see C4 as a clob. Lots of functions tend not to support lobs, or at least don't support them very well. We can pass in lob values, clob and blob, to checksum, and it computes across them fine. And you can also do things like get distinct values and so on. So, okay. Other questions or comments on that before we go back to the slides? Nope. Okay, cool. So some handy functions, some of you will find those very useful. A lot of you are probably like, well, they're interesting, but I'm not sure if I'll use them day to day. Let's move on to a question which tends to come up fairly often. And then people are saying, I've got a table of data. I want to know if anyone has changed that data. So we've inserted it. Has anyone updated it or deleted it after the fact? And out of the box in Oracle database, there isn't really anything that tells you this or isn't guaranteed to tell you this out of the box. There are some tricks you can use, but they're not 100% by default. So how do we do this? Well, we can enable some auditing, have like database auditing, see who's run what commands against the table, or you can have your own custom auditing. Add something like a last updated column to your table, and then have some triggers and so on and so forth. Every time someone runs an update, set the last updated date so you know if something has changed. Key thing here is you need to kind of build this functionality yourself so you know what's actually changed. And there's kind of two high-level reasons you might want to do this. You want to know what's changed because you need to then further process it. You want to find all the invoices that were paid today so you can send them to accounts receivable or whatever it is you need to do. So you find all the changes in a period of time so you can process that data further. Or you might want to find all the changes in a period of time because nobody should have been changing that data, right? It should be static. Nobody should have come in and fiddled with it. So I'm going to focus more on that second use case now, where you want to know if it's changed because nobody was supposed to do that. So the real requirement here is not to know that somebody changed, when it changed, just to stop people changing it. And finding out when it changed is kind of a proxy for it. Because actually stopping people from changing rows in a table is tricky, right? I mean, good place to start, revoke all their update and delete privileges from the table. But that only applies to other users. You've always got full privileges on your own objects. Anyone who's got the able to access as the table owner can get in and update and delete and do whatever the heck they like willy-nilly. So if you really want to stop them, you've got to do things like put in before update or delete triggers which just raise an exception straight away. So if people try and run those things, the statement will fail. good to stop kind of accidental changes, people who either through miscoding or just not paying attention, deleted or updated things they shouldn't have been able to do. But it's not so good about stopping malicious actors, people who are intentionally trying to damage your data in some way. Because if they know what they're doing, they can, they'll be able to bypass your triggers or anything else you put in place to stop them getting in and actually start fiddling around with the data. There are other things we've got to help with this, such as VPD, but like I say, anyone who really knows what they're doing and has got some level of access to the database can almost always find a way around these things. Until we have blockchain tables. So this is one of the things that we've added in 20C, which seems a lot of people quite excited about. The key thing about blockchain tables is they are insert only, or insert mostly. You cannot update data in a blockchain table. So you insert it, leave it there. After some period of time, you may be able to delete it, but you can never actually update it. So we've got an immutable data source here, data store, so nothing's changed. Potentially useful in various kind of audit scenarios or anywhere else where you need an exact record of what happened that no one can tamper with in any way. So how can we do this? How do we create a blockchain table? Well, first step, we've now got this blockchain keyword in the create table command. But there is a little bit more you need to add to this statement. First up, there's this no drop clause. That means, as you might guess from the name, you cannot drop the table until 16 days, in this case, idle. So until nobody's accessed that table or changed that table for 16 days. So, you create that table, you can't drop it straight away. You've got to wait. Also, we talked about deletions. We can say no delete until the data has been present for at least 16 days. So it's not never delete, although you can set that to. You can say no delete. You can lock it from deletions, but the data has to exist for at least a certain number of days before you can remove it. So note, why have I picked 16 other than being a nice power of 2? It is the minimum value you can supply for these. You cannot set these no drop to 1 day or no drop, no delete to 1 day. You have to be at least 16 before you can do these. Makes things a little bit interesting and tricky when it comes to demos and testing, as you'll see in a minute. Final thing is you need to define how you are going to hash the data. So the principle of blockchain works by hashing your data and storing the hash for the previous row, so you can then look at the hashes and see if anything's changed, and we can use that to verify nothing's changed. I'm not going to go into the details of how blockchain really works today. If you want, there's various articles you can look up. But very briefly, database uses hash of the data to know what's stored, and it can compare that to look for changes. Okay, so we've created our table. As we said, there is no delete on this until 16 days after insert. So if we try and delete, what's going to happen? We're going to get this error 5715 error. Delete operation not allowed. Same for updates. You'll never be able to update data in a blockchain table. Operation not allowed. So we can insert, we can delete after a period of time. We can't do, delete everything, unfortunately. You can't truncate as well. Also worth being aware that you can do some DDL operations against a blockchain table, but there are some key ones you cannot do. In particular, you cannot add or remove columns from a blockchain table. Interesting. Okay. That's going to make things potentially a bit challenging for your applications, right? So you can't add columns to a blockchain table after you've created it. You also can't rename it. There's a few other DDL operations, some partition maintenance that you can't do. Can't drop partitions, I believe. You can do things like add constraints. So you can create the table, add primary key, add foreign keys, but you can't modify essentially the structure of that table. Which some of you are probably looking at this and thinking, well, makes things a bit useless or tricky, shall we say, to work with for an application that's going to evolve over time. Well, there is kind of a loophole, which some people might be doing anyway, and that's storing all the data as JSON, right? So we'll have a primary key, sequence or GUID column and stick everything else, all the attributes, in a JSON column, right? Little loophole we can use to get around this, not adding columns. So let's do that. We'll have this JSON column in our table. Now notice I've stored that as a blob. So why a blob? Well, JSON documents can get really, really large, much larger than the varchar 2 limit. So you need to use a large object. Why not CLOB? Text-based blob. Why blob? Well, it is more efficient for storage and it avoids character set conversions. So up to 19C, if you were going to store large JSON objects in your table, we recommended that you used a blob. 20C, we changed that. There is now a native JSON data type. Nice and easy to use. You just call it JSON, right? We just say we've got data type JSON, and this is now stored in a optimized format for the JSON. So essentially, it looks at the structure of the JSON, so it can store it in an internal optimized format. Very useful if you are storing these large JSON objects, because it can be much more efficient for searching and storing or manipulating as we go on. So at this point, I'm going to jump back to my demos. I don't see any other questions or comments on those, but if you've got any, please put them in QA while I bring up my blockchain demo to start with. All right, so blockchain. Let's get rid of some of this stuff to start with. Okay, there we go. So as I said, you try and create the table. You've got to have those 3 additional clauses: no delete, no drop, and a hashing. You have to define those to create a blockchain table. Otherwise, you'll get an exception. So let's create a new blockchain table, no drop for 16 days, and so on and so forth. There we go. I've now got a new blockchain table in the table database. I can stick some values in there, and there we go. I can query it just like a regular table. Now at this point, I'm going to refer you to a table I made earlier. I made this one a while ago, and you can see I've already got some data in there. So how does this blockchain magic actually work? Well, you'll see there's a whole bunch of hidden columns. These are a BC tab, which Oracle uses, the database uses to maintain the integrity of the table, make sure nobody's tampering with it. So we can look, you see there's a whole bunch of information in there about when it was created, sequence number, a nice big hash of the data, so we can see what's going on in there. So we can see there's data in there. Now, if I try and delete from that, as I said, as the thing shows, operation not allowed. Try and update, again, operation not allowed. So we can't go in and manipulate this information. Now, the key thing here is no user can do this. I'm the table owner, so the usual rules about you can do anything to your own tables no longer apply. But also, sys cannot get in and do this stuff. So let's get, I'm now connected sys as sysdba. And we can see in this database, I've got a couple of blockchain tables, which I've created. So there's one I created yesterday and one I created a while ago. So although this was created on the 3rd of January, which is more than the drop time, if I try and drop it, I'm going to get an error. Why? Well, because I manipulated it less than a week ago, less than the drop time. So I've been, the clause is no drop until idle. So we have to not manipulate the data for that time, or not insert new data. This can make things a bit of a challenge when it comes to testing rollout, rollback scripts for blockchain tables. There's basically no way to get rid of them currently, other than restore your database from a backup or something like that. So think about this, also things like continuous integration pipelines. If you're, destroying schemas, creating them as part of continuous integration or testing process, if you've got blockchain tables in there, it's going to create some problems, because we can see we've got that in the blockchain user. We had a table I created yesterday. Again, I can't do a cascade drop of the user. I cannot get rid of it. So that's now stuck for another, whatever, week and a couple of weeks. And the blockchain other table a week or so, before I can actually get rid of these. So key thing to remember here is this is by design. This is how they are supposed to work. The whole fundamental point with these is nobody should be able to tamper with them. And that literally means nobody can tamper these things. So be aware of this. Okay, so far, is blockchain supported in 10G? Nope, these are all new 20C features that I'm talking about today. So you need 20C, which is in preview mode at the moment, to be able to use this. Okay, David, what have we changed system date time? That's a nice one. Okay, so if we do alter system set fixed date equal to, let's set it to 2021, 1st of January next year. So this is a little trick you can use to change the date of sysdate. So we see sysdate's currently 25th February. I set the fixed date to 1st of January next year. We can drop the table now, right? Enough time's elapsed. Yep. Database is smart enough to be able to identify that. We can't drop it. We can't get rid of either of them. If you change things at the operating system level, possibly, I don't know. I haven't been able to, I haven't gone checked or tested that, but you know, obviously, if you're going to start fiddling with the operating system date for your database and putting it forwards and back, that's probably going to create other problems as well. So, yeah, be aware of that. There should probably be some exempt role that can allow these operations. So, I think this is going to be an interesting point about these. Remember, the whole point about blockchain is you cannot change it. As soon as you start allowing exemptions, there's a loophole there, and then it no longer becomes a fundamental, immutable source of truth. So I can see that why people would want this, but yeah, I'm not sure it's going to happen because it kind of breaks the principle of being able to do this. So I can see another question, MPG1. Can we flashback it? That's a good question, actually. Alter table flashback to -1. Have I got the syntax? Because I've not got flashback data archive. Hang on. Someone can just drop me the syntax for flashback table in the chat or something. I can check that, but good way to test it. Blockchain table in test mode. Flashback to timestamp. Oh, thank you. Timestamp. So let's see. Flashback to timestamp. And it's still saying missing archive. If you can dig the syntax out, I'll give it a quick test. I'm not sure. Yep. So blockchain table in test mode. Yeah, again, anything that has test mode exempt, that means that someone in your production database can come in and start manipulating it. The design, this is by design, this is intentional, this is how it's supposed to work. And anything that subverts that then allows anyone to come in potentially and start manipulating it. So I can see why you want to be able to do this, but yeah, this is a very specific use case. This is data you want to insert and never change, basically. So just think about how that's going to work. To timestamp. So the MPG one it is just alter table flashback timestamp. Is that if you could flashback? Flashback. That's why, because I put alter table. Well, flashback table to timestamp. There we go. Row minimum is not enabled. All right. I'm not sure. Enable movement. Okay. Operation not allowed. So there you go. There's your answer. No, you can't. Yeah, so you can't flashback the table. Your flashback query should work, Alexandra. I'll just give that a try. Let's just check that. Yeah, so flashback query works, so you can see deltas, new data coming in, but existing stuff, no. All right, very quickly, JSON. It's actually pretty straightforward. It's just a new data type called JSON. So let's create a table. And the thing is, we can see it's automatically got validation that what you're sticking in is in fact real JSON. I stuck something that's not JSON in, we get a syntax error. So it has to conform to JSON syntax rules. Try and create a standard B-tree index on it. Yep, that's not going to work. Oh dear. From 12.2, we introduced a JSON search index. You can use these to index JSON data, and there's good argument for doing this. Now note, this JSON data type is an internal representation of the data, and currently the client tools do not support that, or at least the version of SQL Developer I'm running doesn't support it. We'll get an unsupported representation. It is not text data, it is binary JSON data. So if you want to see what it is, we can serialize it. Also, we can use dot notation and so on. All the JSON functions you know and love and have been using for hopefully a while now, if you work with JSON, still all work. But dot notation is still returning this as a JSON data type value. So we've got an exception here. We can't, doesn't do that because it's incompatible with string. So you can use these string methods to convert it and actually pull the value out that you're comparing, and you can do things like JSON value. So some things to be aware around selecting and comparing the data, but basically all the existing functions that you know and love work. Also worth mentioning briefly is this new function JSON scaler, which returns it as a JSON value. So for text, numbers, and dates, and nulls, SQL nulls and JSON nulls. I'll just show you very quickly what those are. So text, double quotes, numbers, no quotes, dates and timestamps are in the corresponding ISO formats. A SQL null is in fact the null value, and a JSON null is the text null. So it's not the SQL null, it's the text, N-U-L-L, literally. So JSON in where condition, does it work? I'm not sure what your question is there, T. Mohami. So Judith, yes, JSON functions all work the same. You can see JSON value, extracts that out, returns the string. It's all compatible with all those existing JSON functions and so on. So we can pull that out. All right, we are pretty much on the hour, and that was everything I planned to cover. If anyone's got one or two more questions, then let me know. So, Aravinda, will you make available these scripts? I'll probably need to tidy them up and do some other stuff. Versions of them will appear. A recording of this session will be available, and that will appear later this week sometime. The scripts I'll look and fiddle around with, but you can get the recording and back work. I'll think about what I can do about the scripts. Okay. Yeah, thanks, Rich. I really like the JSON data type. So Sven Voller, is there a way to play around with 20C already yet? So there is a preview version of 20C in Oracle Cloud. So if you've got an Oracle Cloud account, the preview there, it's not available in all regions, or I don't believe it's all available in all regions. So depending on if you've got a cloud account, depending on which regions you're set up have, you may or may not see that. But it is coming on those. So that's the place where you can play with it and see it now. Sven. When's 20C on premise? Later this year, sometime this year. Aravinda, will I make a session about Oracle monoclause? Probably not a session on that on its own. It's a cool feature, but it is quite niche. And I think the pattern matching match recognize clause has kind of taken a lot of the situations you would have used that for. So, I mean, if there's a lot of requests for it, then I'm happy to do one, but I'm not planning to at this stage. All right. Any last questions or comments before we wrap up? So Bye. Thank you all for joining me. For those of you who celebrate such things, it's Shrove Tuesday, Pancake Day today. I'll be going out and cooking a whole bunch myself later on. So I hope you enjoy the rest of your Tuesday, and I hope to see you again next time. Cheerio. Bye-bye.